Suppose we have an alien species, and this species comes in two different appearances or phenotypes. Some aliens have little orange antennae on their heads, while others do not. The instructions for having an antenna are hidden by the instructions for not having an antenna. So we'll call no antenna a big A and an antenna little a. Like humans, our aliens inherit instructions from both their parents. One set from mom, one from dad. So our alien could inherit a big A and not have antenna. He could get a big A from his mom and little a from his dad, and he would still have no antenna because the big A hides the little a. Or he could inherit a little a from both parents and end up having antenna. A pedigree will let us trace the inheritance of that antenna trait. We call big A the dominant allele because it hides little a, our recessive allele. Bob is a male without any antenna. Betty is a female who has antenna. Notice her lovely purple spikes. That's how you tell she's female. When Bob meets Betty, it's obvious he's gonna fall head over heels in love. After a strange alien marriage ritual, Bob and Betty have their first daughter. Betty Sue does not have antenna, but their second child, Bob Jr., does have antenna just like his mother. Their last girl is Betty Lou, and Betty Lou is also going to have antenna. When Betty Lou grows up, she meets Steve, and Betty and Steve have kids of their own. In an actual pedigree, rather than putting in silly faces, we would put in a circle wherever we have a girl. Boys, on the other hand, are shown as squares. We shade in the circles and the squares to show the inheritance of the trait. Everyone on our pedigree who has an antenna is going to be replaced by a shaded in circle or square. Our aliens without antenna are just going to end up being a blank. So this is the pedigree that we will end up with for Bob's family. And we can use this pedigree to try to reconstruct our information about the genotypes or genetic makeup of each individual. We know the genotype of anybody who has antenna. They must be little a, because a big A is dominant and the no antenna trait would hide the little a. What about the rest of our aliens? The rest of the family could either be big A, or big A, because either genotype is going to give them no antenna. We can figure out, though, what some of them are. Bob's son and one of Bob's daughters are little a. They have to get a little a from both parents. So one has to come from mom, but one has to come from dad. So Bob must have a little a. We know he has a big A because he has no antenna. So Bob has to be big A, little a. We can look at Bob's daughter who has no antenna. She has to get one allele, one big A or little a from both of her parents. We know that she got the big A from Bob, so that means she has to get the little a from her mother, and she must also be big A, little a. Bob's granddaughter has a mother who is big A, little a, so she must also have one copy of the little a. We call this being a carrier. Okay. And finally, we have the husband here. He must be big A, little a as well, because he has a child who is little a, little a. So, this father is also a carrier. Let's suppose Bob's granddaughter grows up, gets married, and has a daughter. None of the members of this family have antennae. What would their genotypes be? We have no way of knowing whether these guys are big A, or big A, little a. This daughter could have inherited a little a from her mother and a big A from her father and be big A, little a. But she could also have inherited a big A from both parents. If we don't know, we're going to write this as big A bar. And we don't have any information about him to let us decide whether he's big A, or big A, little a. So we're going to write him as big A bar. Let's look at another pedigree. Again, those that have a trait are going to be shaded in for us. Squares are going to represent males. Circles are going to represent females. A line between a male and a female means they're having kids together. We bring a line down to the kids, and the kids are going to have a line up above them with a little line coming down. We don't put a line directly between two kids because that would make brothers and sisters having kids with each other, and that just would not be right. We know that this trait is recessive because some children have it when neither of their parents do. And if it were dominant, a parent would have to have it to be able to pass it on. We also suspect that this trait is sex-linked. It's carried on the chromosomes that determine sex because only the boys have it. This last pedigree shows the inheritance of eye color in my own family. And in my family, my mother has blue eyes, my son has blue eyes, and my son's grandfather on his father's side also had blue eyes. Blue eyes are recessive. Non-blue eyes are dominant. And there's actually more than one gene that controls eye color. So brown eyes, hazel eyes, green eyes, those are all made possible by the other gene. But let's just look at blue versus not blue. Again, we know it's a recessive trait because it's skipping generations, and children have the trait when neither of their parents do. Since the trait is recessive, we know that anybody who has blue eyes has to be little b, little b. Let's see if we can figure out the rest of them. Well, I must be big B, little b, because my son is gotten a little b from me, and the only thing my mother could give to me was a little b. Similarly, my ex-husband has to be big B, little b. His son inherited a little b from him, and his father had two little b's and could only give him a little b. I don't know the eye color of my ex-husband's other ex-wife, so I'm just going to put a question mark there, but I'm going to include her in the pedigree because I want to include my son's half-brother. And he does not have blue eyes, but without knowing her information, I'm going to have to decide that he is big B bar. My dad has brown eyes, and neither of his kids have blue eyes, so I'm also going to have to decide that he is big B bar. My son's grandmother on the other side is Big B Bar. She doesn't have any children who are little b, so we have no way of knowing whether she's Big B, or Big B, little b. My ex-husband's sister has to be Big B Bar. No, she doesn't. She has to be Big B, little b, because her father has a little b to give to her. My brother, over here, has brown eyes. His wife has green eyes, and neither of his kids have brown eyes. But we know he has to have a little b because that's the only thing my mother has to give him. So he would be Big B, little b. And we have no information to tell us about anybody else, his family. Okay. So this would be a pedigree showing the inheritance of eye color in my family.